This is Chapter 6 and a very brief review of pressure gradient force. A pressure gradient is what you see here in groupings of pressure around 1020 millibars. In other words, there will be pressures of 1020 millibars and above in this area, whereas there will be pressures of 1016 and below in this area, and everything between 1020 and 1016 will be in this area in the middle. So as you can see, you're setting up a differential of gradients between high pressure over here and low pressure over here. And we know that equilibrium is very important, that the high pressure will produce a net force toward the low pressure area and send molecules of air on a horizontal gradient toward the low pressure area. How do we see this on a surface map? We see this in terms of isobars. There's an isobar here at 1012. You see everything to the left is greater than 1012. We see another isobar here of 1008, 1004, 1000. And these surface maps will show isobars at every 4 millibar intervals. The pressure gradient force will always go from high pressure to low pressure. And the pressure gradients will have different distances between them. When the gradient is tight, as it is here, that means there's a high pressure area pretty close to a lower pressure area. In this way, the horizontal movement of air will be brisk. It will move across with a solid wind. When we have a big distance between a high pressure area and a low pressure area, there's not so much of a gradient here. There's not so much of a need for that wind to move quickly. That wind will be a lighter wind in areas where the gradient is wider. In much the same way, when you have a pond next to a stream, you tend to notice that the pond is all placid and the stream has a bubbling brook. There's a faster flow through an area that is tighter, just like there's a faster flow of wind around a tighter pressure gradient. Case in point, Sandy. If you look at the winds, this is a very instructive slide because now we're getting into winds. These are very high-speed winds that are noted by triangles and what are called barbs. The wind always comes from the side that has the triangles and barbs and goes toward the side that has the circle. So this is a south wind, a southerly wind. This is a northeasterly wind, really east-northeasterly wind. You can see here many things in this gradient surface map of Sandy. You can see that the winds are higher where the pressure gradient is lower, and the winds are weaker where the pressure gradient is wider. All right. Relatively, these winds are light compared to seeing the triangle and the barb here. Another really important part about this is you can have the same pressure gradient on land, but you won't get the same wind speed. You see this pressure gradient here. It's pretty tight, a very fast wind speed. You see a very similar pressure gradient over land, lower wind speed. Why? Because there's friction on the air, on the land near the surface. There are trees, there are hills, and these cut down the velocity of the air. So a lot packed into that slide for pressure gradients. Here's another way of looking at pressure gradients. Here's a very, very wide gradient here. Very light winds in this area. Around here, much tighter pressure gradient, higher winds in this area. We talked about friction. That's important. Look this over in Chapter 6 if you need to, and I'll meet you back on the other side.